Welcome to the AI Research Roundup. I'm your host, Alex. Today is May 4th, 2025. Alright, we're looking at RB-Modulation, training free stylization using reference-based modulation. This ICLR conference paper, published just over 3 months ago on January 22nd, presents a really neat training-free plug-and-play solution for personalizing diffusion models. It tackles common issues like unwanted content leakage from reference-style images and tricky content-style mixing using a novel control approach. Okay, so this first figure really illustrates what RB-modulation can do. You see on the left, these reference-style images, like a golden flower or a mosaic teapot. Then, the method applies these styles to totally different subjects like guitars, skyscrapers, or even dragons, following text prompts. It also shows content-style composition using reference content images, like dogs and cats, applying the style without leaking the original pose. It's a pretty effective demonstration. Alright, so building on that visual demonstration, this next figure dives into the mechanics behind RB-Modulation. It presents 2 algorithms. Algorithm 1 outlines the exact theoretical approach using that stochastic optimal controller concept, guiding the diffusion process. Then, Algorithm 2 shows the practical proximal version. This proximal approach is crucial because it approximates the control efficiently, avoiding costly computations, making it much faster for large models. Okay, so moving to the results. This figure really showcases the qualitative performance. It compares RB-Modulation, labeled hours, side by side with other techniques like instant style and style aligned. For instance, applying that thumbs-up style, RB-Modulation generates the requested smiley face or avocado, unlike others that leak the thumb shape. It visually demonstrates much better control, preventing that unwanted information leakage from the reference style image and adhering more closely to prompts. Okay, so beyond those visual comparisons, this table then details the results from a user study. It shows the percentage of human preference for RB-Modulation versus alternatives like instant style and style aligned. The metrics are overall quality, style alignment, and prompt alignment. Well, the numbers clearly show that RB-Modulation was consistently preferred by users across all 3 metrics, often by quite a significant margin, reinforcing those qualitative findings we just saw. Okay. So, following the user study, this figure provides more visual evidence, specifically for content style composition. We see RB-Modulation, again labeled, quote, hours, compared against IP adapter, instant style, and zip LORA. It takes reference content, like a specific dog or sloth, applies various reference styles, and follows prompts, like a dog dancing. The results really highlight how RB-Modulation better combines these elements, keeping the intended content and style while accurately matching the prompt description. Alright, so complementing those composition results, this figure lays out the overall pipeline. It shows the standard denoising score network, but with a key modification. Instead of just cross-attention, they introduce this attention feature aggregation, or AFA module, highlighted in blue. This AFA module is crucial. It processes inputs from both the text encoder and the reference image encoder, effectively disentangling content and style features, which is how it achieves that precise control we saw earlier. So that AFA module really ties the whole pipeline together. Okay, in conclusion, this RB-Modulation method presents a novel, training-free framework for personalizing diffusion models. The key takeaways are its use of stochastic optimal control and that attention feature aggregation, which together provide much finer control over style and content, preventing that unwanted leakage. Well, that's our roundup for today. Thanks for tuning in. I'm Alex.